Alright, so this week we're going to be stepping into kind of some of the more math stuff. Some of these might be things you've had in previous classes. Some of these ideas might be new. Either way, we'll review them or review through them thoroughly, how to the level I expect you to understand. So we're doing the PSS, which is, I forget what it stands for, but it's this weird little slice between chapter 1 and 2 of the book. So we're just doing all of that this week. And so to start out, we're going to talk about measurements. And so, measurements are what we do to understand the dimensions of something. If I want to know how big a room is, I have to measure length and width and do square footage. So sometimes measurements give us values that are used in calculations, like finding that square footage. I'll measure in one direction, I'll measure in another, assuming it's a nice rectangular square or something, and then I'll multiply the two together to get the square footage. So, what do these measurements use to do that? Well, the first thing is we use units, right? So we have to have some way of conveying this information. So if I just say, oh, the room was 24 what? Square feet, square meters, square inches, there's big difference. Square miles, that's a heck of a room. I think that's half an Amazon warehouse right there. The units are important. So what are these units? Well, these are kind of like standards or conventions that are just used to convey info about an object's dimensions. Used to convey info about an object's dimensions. That's a good start. Almost made it through the first sentence today. Alright, so what do I mean by this? Well, we have kind of a definition, like a foot is a certain distance. And so I can go to the store and I can buy 8-foot boards. I know that they're all 8 feet. I don't have to worry about, if I need a certain amount of something. If I need 5 gallons of paint, say, I can go to the paint store, I can buy 5 1-gallon buckets, or I can buy a single 5-gallon bucket. They have that option as well usually. And I know how much I'm getting. So it allows us to not have to worry about, like if I need a certain length of something, like I need a piece of tube and it's like, oh, it's the length of this pen. I don't have to take the pen with me to the store. I can just measure and go, oh yeah, I need 5 inches of tube or whatever, and I can just measure it there and buy it. So it allows us to transmit information independent of some sort of object as a reference point. So that's what it allows us to do. Maybe you never thought about units that way. Well, then you haven't thought about units enough. So we have different types of units for different types of measurements. So I said like 5 gallons of paint. I didn't say 8 feet of paint. I said 8 feet of boards. I didn't say 8 gallons of boards because they're different dimensions I'm talking about. So one of them was for length and one of them was for volume. So different types of measurements, different types of units. So different types of units. Of units. Keep thinking one word ahead here. For different types of dimensions or measurements. And so the ones that are called out in the book specifically, I'll just go through those. There's a lot more. So if we're talking about length, well, they use centimeters, which is part of the metric system. So you have meters, millimeters, centimeters. So we don't really get into it here, but that would be a unit of length. And so it's a distance between 2 objects or endpoints or whatever it might be. 2 walls in a room, ends of a board, whatever they might be. You can measure that length, and centimeters will be a unit you can use for that. Now here in the US, we typically use inches, feet, miles, if it's really far, yards, if, I don't know, you do track, or horse racing or something, or fabric, I guess. They measure fabric in yards. So there's lots of different units, so it's not like this is the only unit of length, but just an example. But if we want to measure mass, we're not going to use centimeters. We'll use grams. So this would be the metric system for mass measurement, which is abbreviated as a G. So centimeters is cm, grams is G. And then volume. Your book reference is milliliters, which is M, lowercase m, capital L. So these are all different types of measurements. So length, mass, and volume, these aren't necessarily related. So, mass is how much stuff there is in an object, and so that can be referred to as grams, how long something is. Centimeters, how much space it takes up, it's volume that it occupies. We can talk about that in milliliters. Now, one other detail about measurements is that they all have errors. So all measurements, they're not perfect. They all have some level of error. And we can maximize, minimize error. You can do a really bad job measuring and just get you can estimate. You don't get a very error-proof measurement that way. Maybe you just happen to estimate spot on, but probably not. You can also use higher-end equipment, and so what we can do is we can minimize this error by using a couple different tricks, but we can never get rid of it. So we can, be more careful. / attentive. You can put a little more thought into your measurement. You can do this by using better equipment. Anything like that. And so essentially you just spend more effort, time, and money to get better measurements. So, for example, you can use a yardstick to measure distance. So it's just a stick with markings on it. It's 1 yard in total length. And maybe you have to measure a distance that's more than that. So you have to kind of like fold it over and do all these things, and your error gets worse and worse as you do that. Or you can use like a laser tape measure. And you just boop. So you spend a bunch of money on the laser tape measure. A yardstick's going to be less than $10 probably. 50 cents if you can find one at a yard sale, I'm sure. You can't get the joke. Or you can get a laser tape measure, not going to be 50 cents at a yard sale. New one will be like $200. But it can get you accuracy within 1/10 of an inch for very, 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 very long distance. Even less than that if you get a really high-end one. Even less error. So you can go like 200 feet plus or minus 1/100 of an inch or something. So you get very accurate, precise measurements. Yardstick can work as well, but you start getting a little bit fuzzier on how much error there is. And so really what it always boils down to is there's sort of, you make a measurement and is it good enough for what you're doing or not? And so, if you're doing carpentry work or something like that, use just a regular tape measure, odds are it's going to be good enough. But if you're doing scientific work, sometimes it's not, and you have to spend tens, maybe hundreds of thousands of dollars on new equipment to make an experiment work to the level of precision that you need to be able to actually have results you can use. So it can get very tricky. So it's just kind of, is it good enough or not? There's always going to be error. Is there too much error, or are we able to work with what we have? That's what it boils down to. Now, how do we know how much error we have in our measurements? Well, for electronic equipment, it's pretty straightforward. You just take that last decimal place, and it's just plus or minus one of those, whatever it reads out to. And so this is anything like electronic balance, stopwatch, not the kind with the hands, but the kind where it's an actual digital stopwatch, which are, I think, more common now. That laser tape measure I referenced earlier, anything where you're looking at like electronic, like LCD or LED screen, and it's giving you numbers. So you're not something where there's like a gauge, like an analog gauge, anything like that. We'll talk about those in a second. But anything where you're looking at a digital screen. And so, for example, you look at your screen and you see something like, you throw something on electronic balance and you get 1.3742 grams. So this is like on your little electronic screen on a balance. Well, and they do go that small, by the way. They go to 1/10 of a milligram. Every digit more expensive than the last. You want a balance that goes as far. They used to be a lot more. Now they're only like $1,000. But if you only want one that goes to nearest milligram, you can get a good one for $100. Go smaller than that, you can get a good one for like $20 to $50. Smaller than that, well, you could probably just get that free coupon at Harbor Freight. There you go. So every digit more expensive than the last. So whenever you throw away data, like you decide just not to write the last number for whatever reason, you're actually you're throwing away, in this case that'd be like $800 for that number that you're wasting. So anyway, the error for this number would be plus or minus just that last digit. So it'd be 0. Be to the nearest 1/10 of a milligram. So 1, 2, 3, 1 grams. So give or take. So there's maybe this isn't a 2. Maybe it should be like 1.9, but you can't read that far, and the instrument isn't able to analyze that far either. So it just calls it a 2, or maybe it's 2, 3. Maybe it's a little bit higher, a little bit lower. So somewhere in that range. It's between 1.3743 and 1.3741 grams. And that little bit of wiggle room at the end, is it really important? Hopefully not, because like I said, every digit's more expensive than the last. So maybe throw more stuff on the balance, or get a really, really, really expensive piece of equipment to go farther than that. So anything, laser tape measure, there's like electronic micrometers to measure how thick something is. Those didn't have digital readouts a lot of times. There's gauge styles as well, but anything where you're just looking at like a screen or some type of, it's only giving you the numbers. You're not interpreting like a needle or something between hash marks, anything like that. Like if you're just looking at an electronic screen, that's your error range, plus or minus that last digit. So for analog equipment, our error is going to be the last digit that's estimated. So we'll talk about this a little bit more involved. Nothing too crazy. But we can estimate a final digit. It's our estimated digit. And so what do I mean by analog equipment? Well, that yardstick I mentioned earlier would be one. Or like a tape measure. So this is the only one I have on hand. This is a sewing tape measure. My wife said you guys would love the clicking sound. And so it measures in inches. And so it goes from 0 to 1 inch. And then what I have is I have markings every, so there's half, quarter, eighth. So every 1/16 of an inch I have a mark. And so I can measure something, to, typically with this style you estimate to the nearest, you just cut it in half again, 1/16 of an inch if you wanted. Like if you're between markings. A lot of times on metric system stuff you can actually go by tenths instead of factors of a half. But what you can do is when you're measuring an object, like say this fine Sharpie marker right here, I can measure it out. A little bit tricky because of the dimensions, but it comes out to be, so it is 5, a little less than 5.5, probably 5 7/8. It doesn't look like it's 5 15/16, but I could estimate that last decimal if I wanted. And so that's what I do, is but I can estimate between the hash marks. So I have an estimated digit at the end. It's a little tricky with these empirical unit stuff because everything's in fractions instead of decimals, but hopefully you followed along there. And so in that case it would be plus or minus 1/16 of an inch. But if you had something that had readouts like 1/10 of an inch, 2/10, 3/10, then you could actually, if those were the markings, you could estimate to the 100th because you could estimate between the markings. And so it's just, you know, for that tape measure I showed, we have plus or minus 1/16 of an inch, to be clear about that. But if I had something like this guy right here, and then 1, 2, 3, 4, 1, 2, 3, 4. If I have markings every 10th, and I'll say this is inches again, why not? Actually, you know what? Let's stick with the last page. We'll call it centimeters, yeah. So this is 1/10 of a centimeter, 2/10, 3/10. I can estimate in here. And so this is going to be plus or minus 0.01 centimeters because I can estimate between my markings. And this is not to scale, by the way. This is definitely not a centimeter. Centimeter is going to be less than an inch. But if I were to measure an object, like say, I don't know, this pen cap, because I can't fit the whole pen in there, and I measure it out, and I'm just going to mark it here. Let's see, so it's 0.5, 0.6, about 0.6, it's a little past 0.65, so I'm going to say it's a little past halfway here. So say that's 0.66 centimeters. I estimated that 6, but it's plus or minus about 0.01 centimeters. That's what we're showing there. So that's how you handle analog equipment. So there's an estimated digit at the end, and it's just plus or minus one of those. So you can go farther than the markings by one decimal place. I can't go 2. I'm not going to be like, oh, that's obviously 0.657. I don't know that far, but I definitely know it's, you know, if this is my halfway mark right here, and I'm a little past it, I'll say it's point, you know, there's a 6 there instead of a 5. So, and then it's past 0.6 overall, so 0.66. All right, so we're going to talk about, so this will kind of wrap up error and measurement here. And so we're going to talk about in the next 2 videos are how we handle these errors mathematically. How do we account for them? So we use significant figures to account for the fact that we have imperfect measurements. Because we're going to use, you know, measurement oftentimes in a calculation. So how do we account for the error in the number mathematically? And then how do we account for that error as we go through a math operation, as we add it to another number or multiply it by another number? And that's what we're going to talk about next. So buckle up, because it's a, you know, I feel like I've taught this more than anything else in chemistry. So maybe you're seeing it for the first time, which is great. I never saw significant figures in high school. I didn't see them until I was taking college classes. So don't worry, I'll go through it all. But it's not the most exciting thing. So just hang in there. And I will go through it. I will be thorough. I'll give examples. We'll have practice sheets for everything. You know, when you're done with the video lecture like normal, so you'll have an opportunity to make sure that it's clicking and you understand it. But, you know, not exactly setting the world on fire this week. Probably, just so you know, this tape measure will be the most exciting thing you see in front of this camera for all the videos this week. So, yeah, kind of taking an aside from the chemistry. We're finally getting into the chemistry, and then we're swerving back into the math here a little bit. So just, you know, hang in there.